Next, let's look at some of the other graphs of the other trig functions. So let's start with tangent. Tangent looks very different. If you don't remember, or if you do remember, I should say, some of the values of tangent are undefined. And what happens there on the graph is that correlates to the graph going up towards infinity or negative infinity in the y direction. And it creates vertical asymptotes. Vertical asymptotes are sort of like imaginary vertical lines. They're actually not on the graph. But they're kind of imaginary lines that block the graph from crossing them. Typically, there are exceptions where graphs will cross vertical asymptotes, but here they will not. So what happens is this is the general tan function. It does keep repeating, so I'll show you Desmos in a second. Its period is pi, not 2 pi like sine and cosine. And what I have here are some values. So tangent of 0 is 0, so you have that center point right here. Tangent of pi over 6 is about 0.6. Tangent of pi over 4 is 1. Tangent of pi over 3 is about 1.7. And then what happens is as you get closer and closer to pi over 2, so these values are actually approaching pi over 2 or 90 degrees. What happens is the tangent value, and you can use a calculator to find these, just starts blowing up very quickly. And it's going higher and higher and higher. And when you get to pi over 2, it's actually undefined. So you have this asymptote there. And the same thing happens in the other direction. As you start going towards negative pi over 2, your values start decreasing. And again, they start decreasing faster and faster as you get towards negative. So that should be a negative pi over 2. And they go towards negative infinity. So this is in general what your tangent function looks like. And again, it keeps repeating over and over again. Let's see. Just find my Desmos screen for a second. Sorry for the delay, guys. Let's see if we can do this again. Desmos graphic. All right, there we go. So here again is going to be the graph. So I'm going to do y equals tangent of x. And you can see it's, we'll zoom it in a little bit there maybe. Let's see if I can get this to, I'll move it a little bit. Oh, there we go. So I zoomed in a little bit and you can see that same pattern just repeats over and over and over again. And you do have these vertical asymptotes there. And again, the vertical asymptotes are really not part of the actual graph. So you don't see them drawn in here. I just did them kind of in light pink on my handout just so you could see where they are. But they do kind of form this block where that graph does not cross. And it just repeats over and over and over again. And the period here is actually pi instead of 2 pi. Now, just like with sine and cosine, we often don't want to have, we often have a more complicated trig function, not just tan x. Maybe we have 3 tan x or tan x plus 5 or something like that. So we can tweak it just like we did with sine and cosine. And here you kind of have the general format here for tweaking it. And this really should probably be more of like a, a curve here. I can draw that a little bit better. And what happens is, there's a few key points here to keep in mind. So you have your same A, B, C that we're used to in this case. I'm not adding in the vertical shift at this point. And you have your vertical asymptotes here. I'm just kind of showing you one period. What happens is that one period of the tan function will lie between negative pi and pi over 2 for whatever bx minus c is. So that will kind of allow you to figure out where your cycle starts and ends on the graph. The period is still pi, but it may, shift left or shift right or something like that. What happens is your x-intercept is halfway between the two asymptotes. So it is at that midpoint in between. And then at your quarter and 3/4 points, you actually have your A value. So amplitude doesn't quite work the same way as sine and cosine because you're going to the infinities, but it is a key value there, and it happens to occur at the quarter mark and 3/4 mark between the asymptotes. So if you take the halfway mark, you cut it in half again, and then you cut this side in half again. You would see those a values as y values there. So let's just look at an example or two of tangent and how to kind of deal with this. And this is going to be a good reference for us. So we're going to graph y equals 2 times tangent x over 2. You don't have to, but if you find it helpful, you can put that in parentheses just to remind you that this is kind of being plugged into the tangent function. And they want it over the grid from negative pi to 3 pi. Now, this isn't necessarily your period here, just where they want to see it on the xy plane. So the first thing I'm going to do is I'm going to remember that we said that one period lies between here. Now, in this case, my bx minus c is just this, right? It's being whatever sort of being plugged into tangent. So I'm going to go ahead and replace this. And I'm going to solve for x here. So I'm actually going to multiply everything by 2. And it happens to cancel on all sides. So we have negative pi is less than x is less than pi. So one period here will actually lie between negative pi and pi. So notice in this case, again, we have changed only the period of tangent function is just pi. And it typically goes between negative pi over 2 and pi over 2. But because we have this, I guess, divider here of 2, it's changed that period. So that's why you have that change here. And then what happens is these two values give you your asymptotes, your vertical asymptotes. So I'm going to just kind of draw this quickly by hand. And I'm just going to really do this as like a rough sketch as I go through. I think this one's easier to just kind of visualize little bit by little bit. So I'm going from negative pi to pi to start. And I do have 2 vertical asymptotes running here and here. Now, again, remember, those lines are not actually on the graph. I'm just drawing them to visually help me out. And then what happens next is I do want to find my x-intercept next. So our x-intercept is always halfway between the 2 asymptotes. This one's pretty easy because I'm going from negative pi to pi. So halfway in between would just be 0, right? If you're not sure for your x-intercepts, what you could always do is add those 2 values together and divide by 2. So if you take negative pi plus pi and divide it by 2, you do get 0. So again, that's the halfway point. Between the asymptotes. So you do actually have an x-intercept right there, in this case, at 0. The other values you may want to find are those a values here, like we mentioned. So notice our a is 2. So I know the y value, but I need to know where the x value is. And those are your quarter and 3/4 points between the asymptotes. Now, how can you find those? So you can just do it. If you can kind of figure it out visually, then that's fine. You may be able to figure out that it's at negative pi over 2 and pi over 2, and that's okay. If you can't do it visually, think about halves. So we know the halfway point is at 0 here. So find half of this. So half of this, I would take negative pi plus my center, which is 0, and divide it by 2. So negative pi over 2. And then for the 3/4 one, do the other side, take the other half. So my center is 0. I'm going out to pi over 2. So what's going to happen here is, your graph looks like this. And what's happening is that at pi over 2, you're getting the value of 2 there. and that negative pi over 2, I didn't do too bad here. You're getting the value of -2. And that comes from the A. And then now we can repeat this same idea. So they actually wanted us to go out to 3 pi here. So if you think about this, this is a distance of 2 pi, right? Pi here and pi here. So if I go out another 2 pi, my graph's a little bit off, we'll call this 3 pi. You're going to see the same thing. So we're doing the same distance from here to here. So it's going to be the same sort of idea. You're going to have another vertical asymptote. You're going to cross in the middle. And again, I'm not finding the other points, but you can keep repeating that cycle as many times as you need to. So notice here that the distance between negative pi to pi is actually 2 pi. So in this case, the period here is 2 pi, and that's why we can find it again here. You're going another distance of 2 pi. All right, let's do one more example here with tangent. And they want us to graph 2 periods. So the first thing we're going to start with is remember that, negative pi over 2, bx minus c to pi over 2 gives 1 period. So it gives where that 1 period would occur. So here, my bx minus c is the x plus pi over 4. And we're going to solve here. We're going to solve for x each time. So I'm going to minus pi over 4 from all sides. I'm just using my techniques for working with linear inequalities. And you do have to do a little bit of common denominators here. So what you get on the right side is going to just be pi over 4. And on the left side, you're at negative 3 pi over 4. So on your graph, this is going to be 1 period. So here will be pi over 4, negative pi over 4, negative pi over 2, negative pi over. So, and then what happens is you have asymptotes here. So you have one here, and then you have another one here. So to find my x-intercept, I'm going halfway in between. So for my x-intercept, I'm taking my 2 asymptotes, negative 3 pi over 4 plus pi over 4. I'm going to add those together and divide by 2. I get negative 2 pi over 4 over 2, or negative pi over 2 divided by 2. And then what happens there? Let's see, let me write this down here. You got to multiply by 1/2. And you get that the x-intercept is going to be at negative pi over 4. So this is where we're going to go ahead and cross that axis. And then you can also find your other values for your asymptote. Now notice here that the value is 1, so your a value would just be 1 here, which means that your y values are 1. And if you're looking for that 4th value, and here's your halfway point, so you want to find halfway in between these two, and you can probably see it right there. But if you're not sure, you can take your asymptote plus the x-intercept, add those and divide by 2. And let's see, we get negative 4 over 4 pi over 2, which is just negative pi over 2. So here's one of them. And that's going to be, here, we'll do this as 1 and negative 1. And then on the other side, for the 3/4 point, you're going from negative pi over 4 up to your asymptote, and you have 0, and 0 over 2 is 0. So up here, you're about right here. And again, you have the same sort of general shape. Again, my graph's not super great here, but you can get the idea. We do want to graph 2 periods here. This is 1 period, so I do want to repeat this. And I'm just going to use the same distance here. So I'm counting by fourths, and there's 1, 2, 3, 4 marks in between. So 1, 2, 3, 4. So I'll be adding another fourth here. So this would be what? So 2 pi over 4, so pi over 2. 3 pi over 4, adding another fourth would be pi, and then 5 pi over 4 there. And I'm going to follow that same general pattern. There would be my other intercept, my other asymptote going right here in the middle. And again, just repeating that. So these are kind of hard to do by hand. You can do the best you can. The really big thing is finding that center value. That's the one that you really need. And it's always halfway in between the 2 asymptotes. So that's actually pretty easy to do. Maybe not easy is the right word, but you can do it. But of course, use your Desmos too to make sure that you are comfortable graphing these as well. Now, I do want to move on to cotangent. So I'm just going to pause the video for a second. I'm going to put the main facts down and you'll see it pop right back up. Okay, we're back. So I also want to do the cotangent function. Remember, it is the reciprocal of tangent. So you're going to see something very similar, but sort of going in opposite direction here. A little bit of a shift as well. So what happens is the original cotangent function, it does repeat too. And you can go into Desmos and try this on your own. It does repeat, but what happens is your asymptotes instead are at 0 for the first one, and then pi after that, and then every pi. So pi, 2 pi, 3 pi, etc., negative pi, and so on. So this does keep repeating just like tangent does. But again, you're going in the opposite direction, sort of from high to low in a way. And then it's a little bit of a shift on where those asymptotes lie. The process for graphing a kind of tweaked cotangent function is very similar to tangent. So the only changes is that your period is between 0 and pi this time, rather than negative pi and negative pi over 2, and pi over 2. So you have that shift. Your asymptotes still occur at those endpoints there. And then you can still find your X-intercept 1/4 and 3/4 points the same way. So again, very, very similar. And we'll just do one example here. So we're going to go ahead and graph 3 cotangent 2x. And don't forget that this part is what's being plugged in. So if it helps you to put parentheses there, you can, but you don't have to. So the first thing I'm going to note is that my period is between 0, and this is my bx minus c here. There's no minus c part, right? It's just the bx, but that's what I would be plugging in here. I am going to solve for x. So I'm going to divide both sides by 2. And I do see that one period will lie between 0 and pi over 2. So because you do have that multiplier by 2 here, the period's changing from pi to pi over 2 length instead. So you do have that change, but it's going to be the same pattern, the same kind of graph. All right, so I'm going to just start by putting, so my first asymptote is here on the axis. And then my next one is going to be at pi over 2. And this keeps repeating. So if I add another pi over 2 here, I would be up at pi. So you're going to have another asymptote at pi, and so on. And same thing going the other direction. You do want to find that X-intercept. That's really the key point that you need here. So your X-intercept is the halfway point in between. So if I'm going from 0 to pi over 2, I'm going to add those together and divide by 2, find that average. Pi over 2 divided by 2 is going to be pi over 4. So that center there is pi over 4, and that is where my X-intercept is. And now you're just going to follow the general pattern. So it's going to be like this. And it would be the same thing here repeated. So you could find this one as well. This is going to be, 3 pi over 4, right? as well. And then you can also use the A. So this is your A here. So that gives you the Y values. So you can find your quarter point, which would be halfway in between here. So going from 0 to pi over 4 and dividing that by 2. And when you do that, you get pi over 8. And then for your 3/4 point, again, if you want to find it, it's halfway between these two. So you're going from pi over 4 plus pi over 2 divided by 2. 3 pi over 4 divided by 2, which is 3 pi over 8. So at here, you'd have the point, and again, your Y value would be at 3 there. And then down here, it's kind of hard to draw this in, it would be 3 pi over 8. Again, you'd have that point and you would be at -3. So just doing a quick sketch here of that cotangent function as well. Again, very similar process to what you would do for tangent. But again, I do recommend, being able to do some of this by hand. You really should be able to find those midpoints and those key values there, understand the general shape or where the asymptotes are. And then you can also use technology to check your work as well for, the rest of it. You don't need to find every single point in between, but as long as you have the general shape, that should be enough to be able to kind of give a rough graph by hand. And of course, use technology if you need to go into really nitty-gritty detail.